Trading. All right, guys, so chapter 7 is what we're going to be starting today. And this here is dealing with rational functions and expressions. What we're talking about with chapter 7 is rational functions and expressions. Now, we've talked about rational numbers at the beginning of the year. And a rational number is any number that can be written as a fraction, written as a ratio. It's going to be a rational number. So rational expressions and equations are going to be fractions with variables, more specifically variables in the denominator. So a rational equation or expression is going to be an equation with a variable in the bottom of the fraction. That's why when we talked about polynomial functions where we said if a variable is in the bottom of the fraction, it is not a polynomial function, because it would be considered a rational equation or rational expression if a variable is in the bottom of a fraction. Now, we're not going to be specifically working with those types of functions today. We're going to start off with talking about direct and inverse variation. And the reason we're starting off with direct and inverse variation is because, well, with inverse variation, we do have a variable in the bottom of a fraction. Now, before we delve straight into inverse variation, the first thing we want to talk about is direct variation. Now, it says here that you've learned direct variation, and we've covered it a little bit. But direct variation is really saying that as one variable increases, the other is going to increase. And as one variable increase or one amount increases, the other is going to decrease. They increase or decrease directly compared to each other. So the amount of increase relative to each other will be the same going up or down. And the equation for direct variation is defined as y is equal to a times x. And we do have it written right here. Now, we could also get the a by itself by dividing x by both sides and say y divided by x is equal to a. Both of these here are direct variation. As one increases, the other increases as well. Any questions on this so far? Now, I did this for last hour, and I think this was kind of helpful, is actually looking at a graphical representation of this. So we can say that y is equal to, let's just say, 3x. Y is equal to 3x. And if we look at this graph here, as the value of x increases, the value of y is increasing. As we go to the left, as x is decreasing or getting a bigger negative, the y is getting smaller, getting to be a bigger negative. Y'all can kind of see this here as we go up and up or down and down. They increase, they're either both increasing or both decreasing. We'd call it a direct variation. So what does that mean for inverse variation? It's flipped. So as one increases, the other is going to, and as one decreases, the other is going to increase. They're going to go in opposite directions. So we have y equals a divided by x. Now we can get the a by itself, and if we do that, we would multiply both sides by x, telling us that x times y is equal to a. We're just getting a by itself. Now for both of these here, a is just a constant term. A is a constant term, which means it's just a number. It could be a whole number, fraction, decimal, positive, negative. It is just a number. And across either one of the functions, the value of a is going to remain the same. So any questions about this here? Now there is one value a cannot be. 0. A cannot be 0, especially with inverse. Now it can be with direct, but not with inverse. Now if we look at this here, well, why don't we keep the same value of a? Because we can say y is equal to 3 divided by x. Now, if we look at this here, let's go the other way. Now, for this blue line, as x gets bigger, going this direction here, what's happening to the value of y? So the value of y is getting closer to what? If we come this way here, it's getting closer to the x-axis. It's getting closer to 0. Mm-hmm. Now the value of x going, let's see here. Edit. And as x is going this direction here, the value of x is getting bigger, but the value of y is getting smaller. It's going to 0. Do y'all see that? Because as we're getting closer to the y-axis. Now this way here, as the value of x is getting or becoming a bigger negative, that function is still going and approaching 0. And even if we go the other direction, as y, the x value is getting smaller, coming closer to 0, the value of y is going down. It's getting bigger. And it's going in an opposite direction. Okay. So we have this inverse variation. And what we want to do is we want to look at these equations here and see, are they direct or inverse variations? Or they could be neither or neither. So when we look at these three here, x times y equals 5, would that be direct, inverse, or neither? So this here, you're saying that it does look very similar to y times x equals a, yes? Does order matter in multiplication? So are these two the exact same? So this here would be what? Inverse. It'd be an inverse variation. If we wanted to, we could have divided both sides by x, which would really just show me that the equation is y is equal to 5 divided by x, which is our inverse variation. We'll look at B here in a second. Let's look at C first. So C. Do we think this is direct, inverse, or neither? Well, it looks a little bit different, doesn't it? In all of the ones that we either have y and x being multiplied together or being divided. We don't have a number with y. So what I could do here is I could multiply both sides by 2. Here the 2 and 2 would cancel out, telling us y is equal to, well, what would that be? That would be direct. Any questions on this here? Well, without doing that there, let's look at it in a little bit different light. We could rewrite this, instead of y divided by 2, I can say, what can we say times y would be the same thing as y divided by 2? Because 1/2 times y is the same as y divided by 2, yes? Because then when we multiply a whole number or a term by a fraction, it's always multiplied by with the numerator. And this here would be equal to x, yes? Now, direct variation, the beginning form that they told us was y equals a times x, yes? A variable is equal to a constant term times a variable. Isn't this still a constant term times a variable is equal to a variable? So y equals, are these essentially saying the exact same thing? Yeah, they just look different. So it would be direct. Any questions on A or C before we look at B? What do we think about B? If we times x by both sides here, we would have xy is equal to x squared minus, if we divide both sides by x, we would have and really that subtraction of 4 and the x and y not being together is really why this is neither. Because when we look at any of these here, for our general terms, y equals a divided by x, or yx equals a, and our y equals ax, or y divided by x is equal to a, when x and y are separated on each side of the equation, so get a highlighter. So we're looking at these two here. How is the constant term and the variable working together? It's in one and two operations. It's either multiplication or division, yes? Now, if the constant term and one of the variables on opposite sides, well, the two variables are either being multiplied or divided, yes? I don't have addition and subtraction with the variables or with a variable and a constant, and we don't have those variables split. So here, well, the variables are split, and I do have an addition or subtraction with a constant. It's not going to be either one. So let's look at these here. I'm going to grab my pen back. Add a fourth one to the mix. I'm going to add that fourth one to it. Now, looking at these four here, which one of these will be neither? Or neither? I would agree.
Neither or neither?
Both? Yeah. It's however you want to pronounce it. Neither, neither.
And maybe 4, does it equal 0?
3 is the only one that is neither.
Neither.
Neither of them. 3 is the only one that is not direct or inverse. So let's just start with from the top with these here. Number 1, what do we think that would be, direct or inverse? It would be direct. How about number 2? It would be inverse. And how about number 4? Right, so this can't equal 0, so what do we need to do? So x times y is equal to, so what would that make it? Inverse. Even though it does have addition and subtraction in it, our two variables are still being multiplied together, and we can set it equal to a constant. Now we know the constant value cannot be 0. The constant value can't be 0. So we do get it set equal to 0. And with any of these direct and inverse variations, the power for either x and y will be 1. They won't have any other exponents. Any questions on these four here? All right. Let's look at these last three, and then we're going to move on to the next part. So going from top to bottom, A would be what? Inverse. Letter B would be? Neither. Neither. And lastly, C would be? Direct. Is really, we can think of this as either 1/10 y equals x, or y is equal to 10x, because we can multiply both sides by 10. Because also, if we look at any of the three here, y equals ax, or y divided by x is equal to a, y is equal to a divided by x, or x times y is equal to a.
I need Paul Eldridge to the office.
In any of these here, inverse, both variables on the same set are being divided, equals a number. But in none of these here, do we have the variables on different sides and a number in the denominator. Does that make sense? Any other questions on these here? Tell whether x and y show a direct inverse or neither. Direct variation, inverse variation, or neither.
It's neither, Trey.
So let's see.
I think it's right.
Now, with both of these here, if they show a direct variation or inverse variation, they do have a constant value, or a constant rate of change between them. Now, we do have two variations of the equations, but the one that's going to be nicely here is our y over x is equal to a for our direct variation, because we can directly relate x and y to that value of a. And for inverse, we can say y times x is equal to a. And if they do have a direct or inverse variation, that value of a should remain the same across all the terms. So for the first one here, if we want to check to see if it's a direct variation, we can take the y values and divide them by their x values. So the first y value we have is -12, and its corresponding x is 2. So -12 divided by 2 is -6. Then the next one we can do is -6 divided by 4. Three over 2, because they both have a common factor of 2, but they don't divide evenly. So -3/2 are -1.5. Well, are these two values the exact same? Well, no. So that tells us it is not a direct variation. Because for it to be a direct variation, the value of a has to be the same for every single set of x and y. So now we can try inverse and multiplying the two together. So we can say 2 times -12, which is -24. Yes. 4 times -6 would be 6 times -4, -24. And lastly, 8 times -3. So here the value of a is the same when we multiply the two together, which is for our what? Inverse. And when we look at this here, the values of x are getting bigger. Because going from 2, 4, 6, 8, the values are getting bigger. But the values of y, guys, are approaching 0. They're getting smaller. Because the values of x are getting bigger, they're approaching infinity, while the values of y are approaching 0. We can't think of it as a negative number bigger, because what is it approaching? 0 and infinity is bigger than 0. So the numbers themselves are technically in a negative sense getting bigger, but we're going from 12 to 6 to 4 to 3. They're getting smaller. So for this here, we can't think of it in the negative sense of negative 3 is bigger than negative 4. We're thinking of it purely in the number sense. Any other questions on A? Let's look at B. Guys, let's focus back in. So, if it is direct variation, y over x should have a constant amount for all the different values of x and y here. So the first one we can check is 2 divided by 1, which is 2. We can do 4 divided by 2, which is 2. Our next one would be, and 8 divided by 3 is 8 over 3, or 2.6 repeated. So 2 and 2/3. So this is not direct because these values are all not the same. So we can try multiplying them together. So we can say 2 times 1 is 2. 2 times 4 is 8. So those don't work. Those don't work. So this is
What is it?
neither, neither. So guys, any questions on these here? We're going to look, guys, we'll look at 2 more of this type, and then we'll move on to the last type of problem. So let's look at the first, number 4. So we have the values of x, negative 4, negative 3, negative 2, and 1. 20, 15, 10, and 5.
Every single one of them. No, this one is actually correct.
And how did you get there?
Because they're all multiples of 5.
Yes. Now, if we do 20 divided by negative 4, it is 15 divided by negative 3, 10 divided by negative 2, and 5 divided by negative 1 is
Shut up, Trey.
So this is direct. And if we look at the x values, negative 4, negative 3, negative 2, and negative 1, they are getting smaller.
Those are getting big.
And if we look at 20, 15, 10, and 5, they are also decreasing. They're both decreasing. They're both getting smaller. And since they're heading in the same direction, most likely it would be direct. Now, if we look at the numbers in 5, well, the x values, 1, 2, 3, 4, are getting, and the y values are going 60, 30, 20, 15, and they are getting smaller. Now, that does help us to tell us that it is an inverse, but the amount of change has to be the same. So to make sure we can do the multiplication, do 1 times 60, which is 2 times 30 is 3 times 20. And lastly, 4 times 15. So this here would be inverse. And that is it. A little bit, as long as kind of all the ones that we've had here, it's all been by a unit of 1 for the x. Now, if they start skipping around with x values or spacing them out, it might be a little bit harder to tell, especially if the spacing between each x is not uniform. Because if the space between the 1 is 4 and then 10, then 5, it's going to be a little harder to determine just by looking at it. This here is the last part. We skipped a few, and I feel like y'all feel comfortable with these here, yes? This is the last thing we're going to look at today. The variables x and y vary inversely. And y equals 4 when x equals 3. Write the equation that relates x and y, then find y when x is equal to negative 2. For these here, we're trying to find two different things. The first is to actually find the equation that we want and find the value of y when x is equal to negative 2. Now, because it tells us the variables x and y vary inversely, we're talking about the equation y is equal to a divided by x, because this is the general equation for inverse variation. Yes. So, well, not y, but almost. Because when we look at this equation, we want it in terms of x and y, which we do have. We need to find the value of a. We need to find the value of the constant term. Now, to do that, we can use the fact that they told us y is 4 when x is 3. So what that means for us here is that the value of y is 4 when the value of x is 3. So we can plug that in to find the value of a. Because if I have the value of a, I have the equation itself. So to find the value of a here, we can do what to both sides? We can multiply both sides by 3. And here the 3 and 3 would cancel, telling us a is equal to 12. So our equation is y is equal to 12 divided by x. So that's half of what we need. We found the equation relating x and y. Now we need to find the value of y when x is negative 2. And what we can do is take the equation and plug negative 2 in for x. And simplify to find the value of y. Well, 12 divided by negative 2 is? So the value of y when x is negative 2 is negative 6. And that's it. Any questions on this here? All right, guys, let's look at one more. Let's focus up here. The variables x and y vary inversely, and y is equal to 8 when x is equal to 4. Write an equation that relates x and y, then find the value of y when x is equal to negative 16. So y is equal to a divided by x. Now they did tell us that y is equal to 8 when x is equal to 4. Yes. Because we can multiply both sides by 4. And 8 times 4 is 32. Here the 4 and 4 would cancel out, telling us that we have a. So y is equal to 32 divided by x. And that would be the equation itself. Now we still need to find the value of y when x is what? Negative 16. So y would be negative 2. Yes. Any questions on any of this here? Do we need to see another example of a problem like this here? And that is it for today. And that is it for 7.1.